All right, everybody, welcome back. It is time to tackle some of these angled plates. So we're going to start with this one. I think it's probably the easiest. So we're going to start with this 2x4 18-degree plate here. We're going to start with the 2x2, and then we're going to add the little wings to it. I think that's maybe the easiest way because if you look at the bottom, which this doesn't really show, but essentially it's a 2x2, and then we've got these um, little wing sections that are added on as little fun bonuses. But I think that's kind of how we'll start. We might change our mind midway through, but who knows? You know, that's the beauty of just trying something for the first time and seeing what happens. So we are going to remove the chamfers. So we're just going to back up in our timeline to get rid of those. And then we're actually probably going to delete these up here as well. Oh, we did a rectangle pattern on that. Yeah, let's get rid of it. We're going to delete that. And that gets rid of those. We're just going to say OK. And got rid of that. So here we are. Here's our 2x2 part. And then we're going to add to it. This is already face offset. So we've already done that, which is good because when you look at the part, a 2x2 fits square on this, like it's the same dimension when you line them up. So there's no overhang there. So that angle starts right at the edge of the 2x2 normal. So I think I'm going to build it from the bottom and look at the bottom when I make the sketch here. So I'm going to use this, and then sure, we'll go in this orientation here. We're going to bring this down, and then it has kind of a flat, and then it goes over to here. And then really we could build one side and then mirror it. It's probably the best way to go about it. But yeah, I think I'm going to do that. I think I'm going to just do one side and then mirror it to the other and call it a day. Let's make some construction lines here. So let's do, actually I think we're okay. We're going to dimension here to here, and this says 18 degrees. Yeah, there's no way. I don't think that's 18 degrees. Let's check. Does that really say 18 degrees? Yeah, I don't know about that. I don't think it's an 18-degree angle. That doesn't seem correct, but we're going to see because this right here is not actually, it's not Lego base. So this is much shorter than Lego base. If it were Lego base, it would stick out and do funky stuff like this. So it isn't that, but actually let's just delete it. Let's do the other side, and we'll do a mirror image of the other side just so we can see it. I'm going to get rid of this, and then I'm just going to take a measurement for the whole thing here. And so this is 1.20607, 1.207, and the actual 2x4 is 1.254. So if I take the difference between those, 1.254 minus 1.207, I get 47 thousandths difference. So really, this is going to be so let's do some constraints here. So first of all, we need to make this horizontal. Sorry about my 3D printer in the background. It's printing, so we're gonna make this equal to this, and this equal to this, and then the dimension from here to here is essentially going to be Lego base times 4 minus 2 times curve minus 0.047 times scale. That doesn't. Okay. And then how do we get this? So if I dimension here to here, what does that come out? Yeah, it's like 27 degrees, not 18. What if I did 28 degrees? This looks too big. That's pretty large there. It's not that big in real life. In real life, that dimension is roughly 45 thousandths. So 45 times scale is like 135. So make this 20. So what do we say? 135, 27 degrees. So it's like 26 and a half degrees. It's kind of a weird number, but I mean, that's really about what it is on that. I think I'm going to go with it. I think I'm going to go with that angle right there. Maybe 27 degrees, but if I did 27, that's too much. So 26, or maybe 26 degrees is what I'm going to go. I don't know where they're coming up with this 18. I don't know what that is. I guess I could look this up, but I'm going to go with it for now, and then we'll deal with it later. When I look at the underside, this offset thickness here runs all the way across. So I'm going to create a line that goes from here all the way across and connects. And then I'm going to do the same thing over here. Connect those. And then there's like a little bit of an uptick, but I'm going to put in some circles so you can see where the studs are going to be based on what we already kind of know dimensionally. So I'm going to project this whole top. So I'm going to project these 4 studs so that you can see those. And then we're going to put some additional studs where they would go. Okay, so we're going to make these horizontally constrained, these vertically constrained, horizontal, horizontal, vertical, horizontal. And then we can dimension here to here. It's going to be Lego base. And from here to here, it's going to be the same. And then we're going to make them equal. Okay. So those are all equal. So now you can see kind of where this is going to fall on here. And then there's like a little piece that goes along here that kind of grabs on or is able to kind of grab onto. That little section. And so there's a piece up here. So there's like a parallel line to this that we're going to do an offset of this going in. And let's make that, see what this is. It's 60 thousandths. So 0.06 times scale. I'm going to trim this up. There we can see where that is. That. Trim this up. Okay. So there's kind of like the outline of the part. Now this one doesn't actually connect to this at all. So we'll make sure that that doesn't touch. I think everything else looks pretty solid. I'm going to make this a X line, and then I don't know if that actually touches or not on this. I don't think it slopes up. I think it basically comes from here and just runs up along this edge. It might come from just trying to figure out what I'm going to do. I'm going to go from here to here. And I'm going to make this a regular line, but I'm going to make it tangent to that, I guess. Maybe like that. And then this also has kind of a line that's tangent here. Pushes against that right there, but there's nothing on this side. So this really isn't doing anything. It's not really grabbing anything, so I'm just going to put it tangent to here, going out this way. So it's 90. We'll just do that. There's that. And then we have the little cutout, but it's not going to even grab this. So it shouldn't really be holding on to that necessarily either. So we're just going to do an offset of this. And we'll do curve. And then that's going to be where it cuts there. And we'll call that a day. So that looks pretty good. I am only going to do one side and then I'll mirror it to the other. But we're going to do a finish on this. We're going to extrude all of the parts up to this top surface. And we also want to do this one. So I'm going to get all the pieces there, and then we'll say OK, and then we're going to share that sketch. And then we're going to do another extrusion. This time we're going to do this, 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 and we're going to do negative hole depth. And that's going to cut up into that space. And then we're going to do a few little fillets just to not make these super sharp. Looks pretty good. And then we're going to say OK. That all looks good. And then we're going to mirror that. So we're going to create a mirror plane. So mid plane from this point here. I guess we could do that. And then we're going to mirror features. And we're going to mirror this extrusion, this one, and this. And the mirror plane is going to be here. I'm going to say OK. and that's going to make our first plate. And again, that looks pretty close to what's there. We just need it to be able to hold or put onto parts. I'm going to save this, and then I'm going to show you how we're going to check it. So I'm going to turn the construction line off, actually. And now let's put it in our assembly file. So we're going to go back to our assembly test, and we're going to put the couple parts here. So let's put this plate in here. I'm going to insert this in. We'll move it over to here. Then we will insert this into it. Perfect. And then I'm going to shoot. I didn't save it. So I'm gonna have to save as and then redo that. So that's my bad. Let's just do that because this shouldn't have been plate 2x2. So this should be a save as. And what's this as official name? Say plate 2x4. That's what we'll call it. Plate 2x4 with angles. Okay. Now I'm going to open up my 2x2 plate and basically undo all this. So delete, delete, delete. To one more edges. This one. Okay. And there we go. There's our 2x2 pack. And that just makes me know that we forgot to do all of our chamfers. So this really we can probably do all of that. And we did all that. Cool. Looks good. We'll save this now. We'll go back to our assembly test. Update. So it should update this. Oh yeah, because we brought in a 2x2 plate. So we're going to delete that one. And we're going to bring in this one. 2x4 with angles. Perfect. I'm going to change the appearance of one of these so I can see it. So I'm going to go into paint, glossy, make one white, one yellow. And then we're going to assemble. So I'm going to do a rigid joint. This pin, top of that one. And pull it up by negative 0.125 times 3. And this is how it looks. So you can see that there's a gap there. That's what it looks like on the real thing. And then when I analyze this, so let me do my inspect tool for section analysis, kind of work through here. These shouldn't really touch. So when we're looking, you can see the stud there doesn't touch. It touches there, tangent to it, and it does grab there. But it's not really grabbing that. And then this isn't even really touching at all. So there's a gap there for that to go around. But now it will grab here, so you can see the interference that's occurring there to hold on to the piece. But I think that looks good for that plate. I mean, I think that's how we want it to sit and look inside of there when it's sitting. The other thing that we can do is we can delete this joint, and I can show you that if I join this piece to here and I do 190 degree, and then bring this up, negative 0.375, and I run this, and I look from a top view, you'll see that it's right on there. So that's perfect. That's how we want that piece to be. It should transition nice and smooth from there to there with that dimension. So I think that's a good piece. I'm happy with that. We'll save it and we'll move on to our next plate. But that's the first of 3 plates that we're going to be making very similar to this. So stop watching, start making, build something great. We'll see you next time.